Hello, here we are with Unit 2, our next lesson in our geometry section. We are now with Lesson 4, going into our irregular, shaded, and composite figures. We are looking at finding the area, perimeter, and then moving then into our volume. All right, so now let's go and continue on with our lesson. Here we are on the bottom of page 39, where we left off. Something to write with. All right, so here we are with our first irregular figure. Now, an irregular figure is just simply a figure that comprises of two different figures put together. So irregular means that they don't have a specific formula for this particular figure on its own. So what they want us to do is first find the length of the missing sides, X and Y, they labeled them, then the perimeter, then the area of the given irregular figure. Make sure we include the proper units. First things first, we first have to identify or look at what they give us. We want to make sure that we already know we have some missing sides because they want us to find them. They labeled them X and Y. We want to identify where they are. But then we also want to look at what they're giving us so we can see if everything else is copacetic, so to speak. Remember, we're dealing with measurements. So dimensions are important for us, or our units. So we want to make sure that they're giving us all the same units. So remember, some conversions might have to come into play. We got to make sure we pay attention to that. So let's take a look. So here we have 4 inches, 8 inches. You see, they gave us an abbreviation for inches, but so that's fine. 9 inches. There's our Y we have to find. Our X we have to find. And here's 6 inches. We know that a double colon here, a double apostrophe there, quotes, means inches. So they gave us 3 representations of the word inches, but they're all in inches. So remember, if they give you inches in feet or inches in miles, you know you have to do some conversions to get everything to be in the same units. But here, we're okay. Now, let's go ahead and find our missing parts. Remember, we're looking for our X and our Y. So now, first things first, here's first. Finding our X. Now, think about what they're giving us and where our X is located. We see that here's our X, and it's parallel to our longest side here, one of the full sides that they give us of our figure, which is 9 inches. If we look at all the other parallel sides here, they gave us our 4 inches up here. So now, if we think about it, if we took these 4 inches and added it to whatever we find out for X, then it makes sense that that should add up to be 9. So, in order to find out what X is, it makes sense that if we took the longest side that we know for sure, which is 9, and subtract out what we know, which is this part, 4 inches, our result should be this missing part of X. So 9 minus 4 leaves us 5 inches. So our X equals 5 inches. All right. Now, finding our Y. Looking at where it is, here's our y value. Our parallel side here's the other side of our figure, our 8. They also gave us this other parallel side here, 6. Again, same deal. So we know the full side is 8. We know this piece here is 6. If we subtract 8 minus 6, then what we get left should be this resulting part, which is our y. So 8 minus 6 gives us, that's right, 2 inches. So our y equals 2 inches. So a lot of it's common sense, thinking about it. They give you all you need to know in the figure in order to find the missing pieces. So now that we have all our missing pieces, now we can go ahead and move into finding our perimeter and our area. Now remember that our perimeter is where we're going to add up all our sides. Okay, add up all of our sides. To find our area, remember this is an irregular figure. So what we're going to do is we're going to break up our figure into 2 parts that's familiar to us, right? So we're going to break it up into 2 basic shapes. So we're going to break up two. All right, so what we're going to do is break them up into 2 basic shapes that we know, that we have formulas for. Find the areas of those 2 shapes, and then add those areas together. Then we'll have the area of the whole entire figure. Okay, let's start with our perimeter. Okay, draw a little separation line here. So part 3 here. Perimeter. We're adding up everything. Now be careful. If you have a lot of sides, sometimes we can go fast and we can forget a side. So I recommend writing it out and then going back and verifying that you've written everything, and then add it up. So start here and work our way around. Doesn't matter where you start, but just start one place and then work your way around. Okay, let's start at the 9 actually, and just work our way counterclockwise. For 9. Plus 8, plus 4, plus 6, plus 5, plus 2. And what I like to do is I count and then go back and count to make sure they match up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Looks like I have everything. Now add these things up. And then our result. What do you get? Yeah, I got 34. We're talking about perimeter, so our dimensions just stay the same, inches. So our perimeter, 34 inches. All right? Simply add up everything. Keep your dimensions the same. All right? Now for our 4th and final part, you're going to go ahead and find the area. So now you're going to take your figure and you're going to break it up. And there's a couple of ways you can do this. Depends on who's looking at it. What I'm going to do is I'm going to go ahead and I'm going to take and draw like an imaginary dotted line right down this edge here and break this up into two parts. I'm going to call this A1 and this is A2. So area 1 and area 2. All right, so here we see that we have a rectangle. Here we have a smaller rectangle, but a rectangle. So what we're going to do is we're going to, here's my structure. The area equals A1 plus A2. Now, they're rectangles. So the area of a rectangle is length times width. So now I'm going to write my formulas out. So length times width plus length times width for my second. It's always good to write a structure out so you'll know exactly what you're doing. And then you can have something to fill in. Now, making sure you're looking at the right dimensions. So for our area for our first rectangle, the length and width, that would be 8 times 4. So we have 8 times 4 plus our second area, we have 5, we found that, and we found the 2. So we have 5 times 2. Okay, so now we just need to do the math, and we're doing it. So 8 times 4 gives us 32, plus 5 times 2 is 10. We add those together, and we get 42. Now remember, we're talking about area. Area, so our inches, we got to square them. Inches squared. So 42 inches squared. All right, so not too bad. Here we had a couple pieces there, things we had to find. Then after we found that, we was able to roll right on through. So looking at your figure, then being able to break it up into pieces to find your area, find missing pieces to write your to find your perimeter. Okay, so make sure you're paying attention to dimensions, making sure you're paying attention to what you need to find. Let's try the next one. Here they are asking us to find the area of the shaded region, including units. They want us to write our answer, the exact answer in terms of pi. Okay, we did that right. In terms of pi means keep that pi sign in your answer. And of course, we're going to give our appropriate units. And then they want to take us to take our answer and approximate it using 3.14, which we know is an approximation for pi. Okay, we'll talk about that in a second. Let's look at our picture. Here they're giving us a circle. So we have a big circle and a smaller circle. It's almost like a picture or piece of paper that's circular, and then somebody cut out a smaller circle from the inside. Okay? They want us to find the area of the shaded region of the circle. So this part right up in there. Now look at the dimensions they gave us. They gave us feet. They told us that the radius of this smaller circle in the circle is 3. And then they gave us this dimension right here that the shaded area is 2 feet. Right there. Now think about what you know. Now, remember, we're trying to find the area of the shaded region. So now, if you think about it now, we have this shaded circle. Logically, if this whole thing was shaded, we could find the area of that whole entire circle. We'll have that. And we could find the area of the small circle inside that's not shaded. We'll have that. But if we only wanted to find the area of the shaded part, then we would take the area of the big circle and subtract the area that we found of the inner circle. And what is ever is left has to be that shaded part. Makes sense, right? I think so. Let's write the structure. All right, here's our structure. We're saying in order to find the area of the shaded, we need to find, and we're going to call this large circle and small circle, okay? The area of the large circle and subtract from it the area of the smaller. And whatever is left has to be that shaded part, right? Now, we need to go and get the formulas for the area of the circle. Here we are with our formula sheet. Here's our circle. Here's the area formula, pi r squared. Now remember, the radius is from the center out to the edge of the circle. So we need pi r squared. So we need pi r squared for our large circle minus pi r squared for our smaller circle. Now let's go and get our information so we can plug it in. Now looking, we need radius. All right, so we need a radius for a large, and we need a radius for a small. What's the radius of the small circle? That's very easy to see. We see coming from the center out here, that's clearly 3 feet. So 3. The radius of the large circle, we have to do a little finagling to find that out. So we have 3 feet here. They told us that this was 2 additional feet out. So 3 plus 2 is going to tell us what the large circle is. So 3 plus 2, that gives us 5 feet. Is everybody all right? Okay. So now we got our information, we can plug it in. Here's the plug-in. For my large circle, I need 5. So we have pi times 5 raised to the second minus pi, and then we need the 3 raised to the second. Okay, now we're ready to do our magic. Looking for that exact answer in terms of pi. So now we have 5 squared, that's 25 pi. Now remember, we are not saying 5 times 5 is, 5 times 2 is 10. That's not what we're saying. We know that now. So make sure you don't make that mistake. So this is 25 pi minus 3 squared is 9, so 9 pi. These are like terms now. So we can combine them. And 25 minus 9 gives us what? Yep, that's what I got. It's 16. Okay. All right, so our answer in terms of pi, 16 pi. So the area of the shaded we found is 16 pi. And then our dimensions are feet squared. Okay. Now, we got that out of the way. Now we just need to find the approximated answer using 3.14. Now, if they tell you to approximate your answer and they tell you to use 3.14, use it. But if they ask you to round your answer or something like that, and they don't tell you to use 3.14, you're going to use your pi button in your calculator. It can make a very big difference in your answer when you're rounding. Okay, here we don't have to round because they didn't ask us to. They just asked us to give the approximate answer. What does that mean? Whatever comes out of our calculator goes on the line. So here we are, we get 16, then times 3.14, and that gives us, you'll see this in the homework, the little squiggly equal sign, that means approximately 50.24 feet squared. All right, so we get 50.24 feet squared. So those are our responses. All right, not too difficult. If there's anything that's going to get us, is probably the working of the algebra part. Okay, but you got your calculator to back you up. Make sure you know what you're doing as far as with your calculator. Please, please, please get that practice in with your calculator. All right? Remember, know that the Learning Commons is there to help you as well as your instructor. Okay, let's go down to our next one. The next one, we have a composite figure. Now, a composite figure is different from an irregular figure because an irregular figure, we actually have to break it up into pieces to make, find the parts in order for us to put them together, okay? To find our areas and then put them together. With composite figures, these parts already have formulas. Okay, so they're similar or close, but these things are structured already that they are not irregular. Okay, so you have here, they're telling you in the write-up part of what you have. So let's read it. It says, given the dimensions of a rectangle, you already know that, that's a real piece there, as 2 feet by 9 feet. Find the perimeter and area of the given composite figure, including units. All right, they already tell us we have a rectangle. Okay, and it measures at 2 feet by 9 feet. So we see here that the dimensions are the same. We don't have to do any conversions. That's good. Let's label. So we have 2 feet by 9 feet. And what we know about our rectangle, let's go ahead and fill in the rest. We know that this is 9 feet here, and this is 2 feet here. What they want us to do is find the perimeter and find the area in terms of pi, okay? So now, looking at what they gave us, what are we missing? They gave us some information. We want to find the perimeter, and we know that the perimeter means to add up all the sides. Do we have all the sides yet? Is the question. The answer would be no, right? We have this, this, and this. That's great. But we don't have this part up here. We don't know what that is yet, right? This right here, this is a half of a circle. Do we agree? Some people will say a semicircle. We can keep it nice and simple and just say a half a circle. So this is a half of a circle. Okay, we don't know that yet. So we got to find that. Then we can find the perimeter. Okay? Let's go for it. So our first part one. Find the circumference of the half a circle. I'm just going to keep it simple. All right, so we need to find the circumference. We would say perimeter, but perimeter for a circle is circumference. Here we are going to our formula sheet. We need the circumference formula. Remember, we have two of them to choose from, pi d or 2 pi r. And in our formula, our problem, they gave us a diameter. So I'm going to use pi d. So remember, pi d is the circumference of the whole entire circle, but I only need half of it. So circumference equals half pi times d. So I only need half of it. So now I'm ready to plug it in and find it out. So we have 1/2 pi. My diameter is 2. So now we find out the circumference. The 2's cancel, don't it? Look at that. And only leave us pi. Pi feet. Sometimes it's just that simple, y'all. It's not a trick, okay? So we found out that this part up here, this arch here, is just pi, okay? Now, we can find the perimeter. It's our second part. Here we go. Here we are finding the perimeter. So the perimeter says P equals, and then we're going to add up all the stuff now. So we have 9 plus 2 plus 9 plus what we just found, that arch there, is pi. Now you can only combine like terms now. Don't make no stuff up. Okay, so let's add it all up and see what we get. So we get 9 plus 9 plus 2, that's 20. 20 plus this pi sign here, which we can only just add the pi. Do not say 20 pi. You can't change addition to multiplication. All right, we're adding. And we can't add unlike terms. So think of this as an x. So if you have 20 plus x, then you just got 20 plus x. You don't change it to 20x. You don't change it to multiplication, okay? So you're going to do the same thing with that pi. And that's our answer in terms of pi. But now remember, we've got to put some dimensions on it. So now that we have these two things, we got to couple them together. We got to put some parentheses on them. And since both of them have the dimensions of feet, that's why we got to couple them together so we can put our feet on there. So our perimeter is 20 plus pi in parentheses, and then put your feet. Now I know it looks unfinished, and in our spirits we want to just throw it in that calculator and get some decimal number, but that's not what they're asking us to do. They asked us for the exact answer in terms of pi. So look out for that on the homework, and definitely look out for it on the test. Are we all right? Again, in terms of pi means, leave pi alone. That's what it means. Okay? All right. Now let's look at our area. Here we are finding the area. Now the area, again, we got to write our structure out, because why? We have two different things going on here. We have this rectangle that they told us about, And we now know we have this half circle that we have to find the area of. So let's write our structure. So we have the area equals the area of a rectangle plus the area of a half circle. Keep it consistent, okay? Now that we have our pieces listed out, now we got to go find our formulas. So we know the area of a rectangle, put it in there. Area of a rectangle, we know is length times width. The area of a circle, remember we only need half of it. So area of a circle is, now remember, if you don't remember, you got your circle, your formula sheet, but we did it up at the top. So the area of our circle is pi r squared. So remember, we only need half of it. So 1/2 pi r squared. Again, this is why it's important to write your structure out so you can see what you're plugging in, what it's going to be. Now, let's go ahead and fill it in. We need our length and our width for our rectangle. We know that's 9 and 2. So 9 times 2 plus half a circle. And what's the area of our circle? We have pi. And then we need a radius. Now, they gave us a diameter of 2. So if D equals 2, then the radius equals 1. It could be that, okay? So 1. There's our plug-in. Now we're working it. So we have area equals 9 times 2, 18. Then we have, starting in the middle, working our way out. 1 squared is just 1. 1 times pi is just pi. So inside of here, all we get is just pi. Is everybody all right with that? All right. Don't overthink it. It is what it is. So if this just comes out as pi, pi times 1/2 is just 1/2 pi. Now it is okay if you put pi over 2. It's the same thing, all right? But 1/2 pi, fine. And that's all we can do. We can't combine these because they're not like terms. So now again, we need our dimensions. We're going to hold this together since there are 2 separate things being added. And then our dimensions are going to be feet squared because we're dealing with area now. So we get 18 plus 1/2 pi, then feet squared. So first, we had to find our missing part. Then we found our perimeter by adding up all the parts. Then we found the area. We wrote out our structure, found our formulas to correspond, filled in our information, and then evaluated it. All right. Looking at part B. It says, find the area of the given composite figure. Now, here's a chance. Now, we've already done 2 examples of what's going on here. Now, we've done some examples. Be paying attention to what's going on. Pause the video here. Give it a try. Looking for the area of the whole entire figure. See what you can find out. Make sure you pay attention to what they give you and what they don't. See what happens, and then I'll see you when you get back. All right. So now let's look at it. It says find the area of the composite figure. So again, here we have this figure. When you look at it, you have to train your eye to see what figures you have there. What are you looking at? When I look at this, I see a rectangle and a triangle. I'm sure you saw that too. I'm going to go ahead and I'm going to separate it. Okay, so there's my rectangle down here, and this is my triangle right here. Okay, and then I know it makes that 90 degrees. Now I'm going to look at the dimensions that they gave me and see if I have everything represented. I have this length here, that's 9, that's good. This is 6 right here. Okay, they tell me that the whole entire thing here is 10. For the triangle, I know this is going to be 9 because they tell us that down here. But what is this right here? This is the height of the triangle, and I don't see any indication of that. Do you see that? They didn't give us that part. We might be having to find that. Because if we're going to find the area of the triangle, we're going to need the height. Now, if you didn't see it right off, when you start plugging it into the formula, you're going to see that you need it. So I know that you found it. Here they told me the whole entire height of the whole entire figure. They gave me the height of just the bottom part of the figure. So if we look, we're missing this part right here. You see? This part. So now what did you get right there is the question. All right. Remember, this is 10, and they told us what this was 6. So 10 minus 6 should tell me that this is, that's right, it's 4. So now we have all the pieces. All right. Now let's get our structure. We identified the shapes that we have. Let's write it out. So we have the area equals. We have the area of a rectangle plus the area of a triangle. So now we need to get our formulas. Again, we know what the area of a rectangle is length times width. The area of a triangle, let's take a look, make sure that we're okay with it. Triangle, here's the triangle, and the area is 1/2 base times the height. So there's the height, here's the base, I got it. So 1/2 base times height. So now I have my formulas to support my structure. Now I'm ready to plug some stuff in. Okay, now I have my length and my width for my rectangle, which is 9 times 6 plus 1/2. Now I need the base of my triangle, which we know is 9 again. And then the height that we found of our triangle is 4. There's my plug-in. Now I'm ready to evaluate. So here we go. We're multiplying. 9 times 6, okay, 54. And then here we have 1/2 times 9 times 4. Now, if you want, you put in this in your calculator, that's fine. Or I see that I can simplify 2 into 4. So 2 goes into 4 2 times. And then I can multiply a little simply there. 9 times 2 gives me 18. Didn't need a calculator there, as much as I thought I did. Now I can add these together. And that's going to give me my total area right here. Area equals, okay, and what do we get? 72. They didn't give us any dimensions here, so we're just going to use the word units just to give us some fill-in so we can make sure we know what's going to happen. We're talking about area, we got to take action on the units. So 72 units squared. Okay. All right. How are we feeling about it? It's not too bad, right? We're just thinking about what's going on in the picture, breaking it up. That's all we're doing. Looking at C, finishing up. It says find the area of the shaded region again, including the units. Now look at what they give you now. Analyze your picture, making sure that got the right dimensions. All the dimensions the same. Centimeters, 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 centimeters. Okay, that looks good. Now let's identify what figures we're talking about. Look at it. Should see big picture. Always look at the big picture. I see a rectangle for sure. Rectangle that has a triangle cut out. So a rectangle and a triangle. Okay, I agree. Here's my structure. So we're trying to find the area of the shaded. Now, if you noticed, when you're finding the area of the shaded region, you're always going to subtract. When you're finding the area of a composite figure or irregular figure, you're adding. Use that. It helps. So now, if I take my big picture, which is my rectangle, so the area of my rectangle, and subtract out the area of this triangle, then I should have the shaded region left over. So somebody took a pair of scissors to this rectangular piece of paper and they cut out a triangle. That's what happens. They want us to tell what is the area of the leftover piece of paper. Okay, so now let's get our formulas and then we'll come on back. Again, we know what the area of a rectangle is. That is length times width. And then the area of a triangle, we just looked at that. So minus 1/2 base times height. Okay, now we need to figure out if we're missing any pieces. Okay, so we need, let's see, length times width for the rectangle. Do we have it? We have length, we have width. Got it. 18 times 9 minus. Now we need a base and a height for our triangle. Here's my triangle. We definitely have a height because we have the 9 here. And we know that this, okay, is our height. So same as the width of the rectangle. So we have the height. The base is this part right here, which we see we don't have. We got to find this, right? So remember, we see that the whole length of our rectangle is 18. But then they gave us this piece right here, 3 centimeters, and this is 2 centimeters. So finding our missing piece. We have 18 minus this 3 minus this 2, and whatever is left should be this part right here. Now you could probably do this on your fingers. I would, okay, and I am. So we have 18 minus 3 That's 17, 16, 15 minus 2, 14, 13. There you go. So we get 13 centimeters. So this part right here is 13 centimeters. So now we found our missing piece. We can finish our triangle part. So we have 1/2. The base now we know is 13 and our height is 9. Is everybody all right so far? If not, go back and rewind just a little bit and I'll walk you back through. All right. Now we have to do our math. All right, so we can find out what's going on. So 18 times 9 gave us 162. Did the calculations. Minus, and then we have 1/2 times 13 times 9. Now remember, these are all over 1. So multiply these together and then divide by your 2, and that's going to give you a decimal number, and that's going to be 58.5. Now subtract. Okay, what are we getting? Okay, so we get 103.5. Remember, our dimensions is centimeters. We're talking about area, so centimeters squared. So 103.5 centimeters squared. Okay. All right. Always write your structure. Think about what you're doing. Shaded regions, you're subtracting. Composite and irregular, you're adding. Look at your dimensions. Make sure they're all the same. If they're not, convert. Look to see if you're missing some pieces. If you're missing something, find it. Go get your formulas. Plug in your information. Then do your calculations. Whatever is up there is your answer. Again, pay attention to how they want you to enter your answer. Whether it's exact in terms of pi, whether it's exact, whether it's approximate, if it's approximate rounded to the nearest place. You got to know those different forms. One more piece of helpful information for the test. On your homework, you're going to work a problem that has to deal with the ladybug going around a racetrack. Do that problem. Oh, that's going to be a good one. I wonder why. Must be going to be on the test, maybe problem number 7. I don't know. Do it. It's going to be really important. There should be another problem on there that has to do with a picture frame and framing it and putting a border around it. It's the same principle, okay? Think about what's happening. Draw it out. That's going to be the key. Draw it out, and then you'll see exactly what's happening. All right. Good luck with the lesson. I hope this helps, and I'll see you on the next go round.